Okay, it's recording. Now we are going to see two input NOR gate. Select your library. My library name is VLSI, and go to file, click new, and the cell view NOR 2, which is a 2 input NOR gate. Ensure view and type is schematic. Click OK, and this is our schematic editor window. Expand it and press on create instance. Here I am using a 50 nanometer PDK. You can use your 45 nanometer or 90 or 180 nanometer GPDK, and select the PMOS there, and I am changing this PMOS into PFET, and you don't need to change this. Keep the setting as a default setting, don't change anything. Press side, and you see here is an PMOS symbol. We need to place the PMOS serially, and again go to the create instance. Now select the NMOS, and you don't change this, keep it your default setting, and click hide. Now I am placing my NMOS and parallel. Okay, press W for wire. Now just connect everything. Okay, I already said that if a transistor is NMOS, the body should be always at ground. If the transistor is in a PMOS, the body should be always on a VDD. And just extend the wires. We can give a name for it. Okay, now just press the create pin and change the direction to input. The pins are A, B, VDD, VSS. Press side, A, B, press R to rotate, VDD, VSS, and change the direction as an output. Name it as out. You can name it as Y, X, or something what you need. I am naming it as out. Hide, placing here. Press W and just connect it. Okay, now click here. This is a create wire name A B B, and this wire is connected to the pin A, and this wire is connected to pin A, and this is connected to B, and also this is connected to B. Okay, now just press check and save. See here, NOR2 schematic is saved. Okay, now we need to create the symbol for this. For that, go to create cell view, from cell view. Check this, from view schematic to symbol. Ensure this and click OK. Always give the VDD as top and VSS to bottom. Okay, this is our symbol window. Just double click in the instance name and name it as NOR2, which is 2 input NOR gate. Press enter, just move it away. Click this X mark, this is an delete, and delete this PR boundary and this line and this part name. We don't need a part name. The instance name is important. Just take everything outside. Now draw the NOR gate and use this arc symbol. use this circle. Now place everything by attaching it. VSS VDD, and this is my first input signal A, and this is the second input signal B, and place the instance name at the inside. Okay, now we need to create the PR boundary. For that, to go to create selection box and click the automatic. PR boundary will create automatically, and press check and save. You can see an R2 symbol saved. Okay, now just go to launch. No, okay, we created the symbol. Now we need to create the test bench for this. For that, exit, file, new, cell view, and now this is R2 test. Okay, just go to create instance, VLSI, R2 symbol, and press hide, place it, press escape. Now go to the analog lib, search for VDC, press R to rotate. Now search for V pulse, hide it, and this pulse is for B and this pulse is for A, and search for GND, hide, place here and here, and press the create pin. We need to create an output pin, out, ensure the direction is output, press hide, place it, just press W, it will go to wire mode, and just connect everything to ground, VSS VDD on the negative terminal to ground, and this is for pin A and this is for pin B, and this is the naming wire. Create wire name, press this A, B, press enter, keep this as wire name A and this wire name as a B. Now we need to give the parameters. Press this DC voltage supply, press Q. Q will get you into the properties. The DC voltage, here I'm using 0.5 volt DC. You can use 1 volt, 1.3, 3.35 or something, whatever you need. And I'm giving the pulse width, pulse is 0.5 volt, period is 20 nanosecond. I don't need delay. Rise time is 0.5 nano, the fall time is 0.5 nanosecond, and the width is 10 nanosecond. Okay, and now changing the properties of pulse, 0.5, period is 10 nanosecond, and I'm adding just 3 nanosecond as a delay, and rise time is 0.5 nano, and fall time is 0.5 nanosecond, and the pulse width is 5 nanosecond. Press OK, check and save, launch ADEL, analog design environment. L represent the size. Okay, now press the setup. You can skip this step. I am changing the simulator. You can use Spectre, so just leave it. I am using HSpace, so I am changing this to HSpace. Pressing OK. No. Okay, you need to declare your model library. Your inside your model library there is an measurements of NMOS and PMOS that don't need now. Okay, don't concentrate. Model library, and my model library is here, and you need to click your model library and press apply. Okay, then output to be plotted, select and design A, B, and out as my output. Analysis, this is transient analysis, starting at 0, stop at 60 nanosecond, step at 0.1 nanosecond. Press OK, and just press the run button, it will run. Okay, here we got a waveform, changing the width as a medium and the style as a solid. Okay, you see, this is the NOR gate, 2 input NOR gate. If both of the input is 0, the output should be 1. Here we are seeing the correct waveform simulation output. Okay, fine. You can change the simulation input, like you can change the pulse width, you can change the fall time and rise time, and you can try it your own. Okay, we can meet in next video.